the Bloemfontein International Airport, where the South African Weather Service offices are based. Welcome to the Forecasting Weather Office, the Bloemfontein Forecasting Weather Office. So in terms of forecasting is a short-term prediction of weather up to 7 days. There is 3 disciplines of weather forecasting. One is your public weather forecasting, your aviation weather forecasting, and your marine weather forecasting. Since Bloemfontein Weather Office is an inland station, we only deal with aviation weather forecasting and public weather forecasting. So for those of you that are interested in becoming weather forecasters, that are interested in joining the company South African Weather Service, there's plenty of opportunities for you. One can be an air quality specialist, data specialist, med technician. You can be a researcher, or you can also be a weather forecaster. But the purpose of this video, or the main focus of this video, will be weather forecasting. So weather forecasting, for those of you that are interested in weather forecasting, in high school or your matric, we need a level 4 in maths, mathematics, pure mathematics, and you need a level 4, a minimum of level 4 also in physical sciences. So there's 2 ways in which you can enroll in the course of meteorology. So one way in which you can enroll and become a weather forecaster is by doing a bridging course, is by doing a BSc majoring in maths and have at least a level 1 or first year physics. So by then you can complete your BSc majoring in maths. After that you can go on to the University of Pretoria. You apply for a bridging course. It will take you 10 months. After that you enroll for a BSc in honors in meteorology. After completing those honors, you then enroll for a course in weather forecasting. Another way in which you can become a weather forecaster is if you can study a BSc in meteorology. You study that BSc in meteorology, and then after the BSc in meteorology, you do your honors in meteorology as well. After that, you do your forecasting training and become a weather forecaster. So these are the institutions that you can enroll in here in South Africa. One of them is your University of Pretoria, University of Free State, and the University of KwaZulu-Natal. South African Weather Service as a company, it also offers bursaries for those that are interested in joining the company. So you just need to visit our website, which is www.weathersa.co.za. All the bursary information is there on that website. What you are looking at now, we are looking at one of our observation tools. This one is called a satellite image. What you see here, a satellite image, we have different channels of satellite images. So one of the one that we are looking at right now, we are looking at the day natural colors. All these colors, like your green, red, and blue that you see here, these are showing us, this is our lightning detection network. It shows us areas where there is lightning. The blue are showing us clouds and other cloud information. We also have what you call an MSRGB, which is a combination of a red, green, and blue colors. It gives us this display. And we also have what you call for your upper levels. We also have a water vapor image. This is how it looks like. It gives us the upper, what's going on in the upper levels. This is another example of observation tool. This one is called the radar display. What you are looking at here, you are looking at supercell system southwest of Potchefstroom. So this is Potchefstroom, southwest of Potchefstroom, and supercell system are usually associated with heavy downpours in the form of flooding. They are associated with large amount of small hail or large hail. They are also associated with strong damaging winds, sometimes your tornadoes. This is this is another observation tool that we use. It's called the Visalis display system. So what you basically see here is it's the conditions at the airport, the weather conditions. For instance, you have your temperature over here, your dew point temperature, and your pressure, which is in hectopascals. Temperature is degrees Celsius. You can see here over this. This is runway number 1. It shows us the speed and direction on runway number 1. Also, what you can see on the Vaisala system, it also has this product that our colleagues from the observation site that they create every 30 minutes. It's called a meter. So we are able to communicate, they are able to communicate the information to us without us going to them or without any physical contact. Another thing that we are able to see here on the Vaisala system, it is the lightning. We are able to detect lightning. As you can see on this panel, there is also a field for lightning. So what it does is that it has a 55-kilometer radius from the airport, so it's able to detect lightning up to 55 kilometers from the airport. Those are the few things that or some of the things that we see from this Vaisala system. What you're looking at now, you are looking at different numerical weather prediction tools or models. So these models, they give us the ability for us to be able to predict the weather conditions ahead of time. So what we basically looking at over here, we are looking at your you have your windy that has different models. You have your other models that we have also as well. You have your unified model and an SA4 that we use in-house here. So what it basically does, it's part of the forecasting process that the numerical weather prediction tools, they help us to be able to forecast the conditions ahead of time. As part of our responsibility as South African Weather Service, we have to warn the public of severe weather conditions. We have moved from a probabilistic type of a warning system into an impact-based warning system. So at first we used to warn and say we are expecting 50 millimeters of rainfall in 24 hours over Bloemfontein, and a lot of people were struggling to understand that. Now we have moved into an impact-based warning system where the main focus is on the impacts. What will the weather do? So for instance, now we have your colors. We also have the levels of the impact, the way in which we come about the warnings, the levels and the colors. We decide on the likelihood and the impact. So our likelihood ranges from very low, medium up to high, and the impacts, they range from minimal, minor, significant and severe impacts. So now when we have to decide on the level and the color, we use the likelihood and the impact. What is the likelihood of the event that we are warning for occurring, and also what impact will it have on the ground? For instance, now in terms of the impact-based warning system, an example would be a yellow level 2 warning for severe thunderstorms resulting in localized flooding and difficult driving conditions over Bloemfontein. At least with that type of a warning system, you know what it will do on the ground as compared to the numbers that we were first giving at first in our probabilistic type of a warning system. Also with this type of a warning system, we're using colors. Colors are easier to understand as compared to the words or just the numbers. When we decided on this type of a warning system, there were collaboration from the people on the ground, your disaster managers and various stakeholders were involved. It is not only a product that South African Weather Service decided on their own. There were collaboration from different stakeholders. This is our website as South African Weather Service. To visit this website, you click on www.weathersa.co.za. Just like I've mentioned before on the video that we are here at the Bloemfontein office. We have public weather products and aviation forecasting products. I will start off by showing you one of the one of the forecasting products that we issue as the Bloemfontein weather office. It is, if you go on to forecast and you go on to the regional forecast. So basically on a regional forecast, this is part of the public weather forecasting products. What we have is the first part consists of the severe weather alerts, where you have your impact based warnings, and then you have your regional forecast. An example of a regional forecast would be a Gauteng. So what we see here, it's saying cloudy and cool with scattered showers and thunder showers. So basically, this is how we compile a regional forecast. It's different from what we call a traveler's forecast. Let me just show you another example of public weather forecast product that we create, which is called the traveler's forecast. Here the difference is that on a traveler's forecast, you can see that it also starts with the severe weather alerts, and then here it gives us a breakdown of the cities, specific cities in each and every province. For instance, an example would be for Pretoria. It says cloudy with scattered showers and thunder showers. It gives the temperatures in Pretoria, which are 16 and 24. This is used for people that are traveling. For instance, if you want to travel from one city to the next, you can just open up this product and be able to see the weather conditions of that city for that specific day. Another type of forecasting that we do is aviation weather forecasting. So this is our aviation weather page. This one is only limited to the users that are authorized. Not everyone can be able to access this information. So as part of the aviation weather products, we have a few products that we create for the aviation community. For instance, if a pilot wants to take off from Bloemfontein, we have what you call a takeoff data. Here is an example of a takeoff data product. It gives you the conditions at the airport or specific airports at different times. The time is in Zulu time, which is South African time -2, and then what you can see here is that at 10 Zulu, which is 12 local time, the temperatures are expected to be 25 degrees Celsius. The pressure, it's 1018 hectopascals. Then the wind direction at speed, it's variable 3 knots. Also, in addition to this, the pilots also use a product called a terminal aerodrome forecast. So also a terminal aerodrome forecast, it's also a product that we create for specific terminals or airports. So it also gives us conditions at specific times in the airport. It gives you the weather. This is an example of a takeoff of a terminal aerodrome forecast, also known as the TAF. For cases where we have to guide pilots for long flights, we use what we call a significant weather chart. So in a significant weather chart, here is an example of a significant weather chart. A significant weather chart, it gives us some significant information ranging from your cloud base, your weather, your turbulence, your cloud type, your cloud amounts, your base and the tops. There is also what you see here in these lines that you see. They represent boundaries across the region where specific or different weather parameters are expected. For instance, over this boundary, we are expecting a base of 6,500 and a top of 8,000. These conditions are different from these conditions that we are expecting over this boundary. In addition to a sick weather chart, we also issue what we call your warnings. We also have your aerodrome warnings here. It's a pity that at the moment now we don't have your aerodrome warnings, but part of the products that we issue, it's your aerodrome warnings. We also have your wind charts and all the products that the aviation community utilizes. So we post everything, or we upload each and every products here. Sometimes the pilots don't have to call us, or any aviation community that are using these products don't have to call us directly. They can log on to the website, navigate through the website, and that's where they find our products as well.